Hello and welcome to this video on adding rational expressions with unlike denominators. So this is only a bunch of examples where I'm just adding two fractions, and the fractions start off having different denominators. And of course, to add and subtract, we need to get those denominators to be the same by changing the fractions to equivalent fractions with a common denominator. So let me begin my examples. I have many today. All right, my first involves just a couple numbers, no variables yet. So I have to find the sum, right? Find each sum, and of course at the end, when I put these together and make a single fraction, I wish to simplify my final result, simplify the sum, meaning I don't want to have a common factor in the numerator and denominator. Alright, so in finding the sum of two fractions, two rational expressions, I have 5/12 plus 5/18. Again, you cannot just add the numerators and add the denominators. This is not 10/30ths. Please do not do that. That is incorrect. What we need to do is rewrite each of these fractions as a fraction that's equivalent to it, has the same value, but so that the two new fractions have the same denominator, and then we can add. So hopefully recall this, only when I have two fractions, say a over c, and I add it to another fraction, b over c, right? Only when the two denominators are the same can I put the fractions together, can I create the sum. And in that sum, the denominator that is the same, the common denominator, sticks around. Right? That is still the denominator. And the only thing we're combining, taking the sum of, are the numerators. Right? So the numerator of the sum will be the sum of the two numerators of the fractions. Alright, so the first step in this, and I'm going to, in this example with just numbers, and in all the other examples I have where there are variables in the denominators, the steps, the procedure will not change. So the first step in this is to find what they call the LCD. Right? Now I've put up videos before on finding what's called the LCD. This is the least common denominator, or in other words, the least common multiple of the denominators. So you can go looking for the videos on that from me or from elsewhere, or read your texts on finding the least common denominator of several fractions. Alright, so here I'm going to first find the LCD that's focusing on the two denominators. So one of the denominators is the number 12. And to do this, to find this LCD, I'm going to factor 12 completely, factor all the denominators completely. So 12 breaks down to 2 times 2 times 3, right? 4 times 3, 12. And if you'd like, you can write 2 times 2 as 2 squared, right? 2 to the second power. In fact, I'll do that over here if you'd like, right? 2 squared times 3. And then the other denominator, pardon me, 18, that's 2 times 9, and then 9 breaks down to 3 times 3, so not 2 times 3 times 3, or 2 times, and then the 3 times 3 is 3 to the second power, 3 squared. Okay, so first you factor the denominators completely. Then the LCD, the least common denominator or least common multiple of the denominators, the factorization for the LCD will contain all the prime factors that show up in the factorizations of the denominators. So you got 2's and 3's, so the LCD is going to have 2 to some power times 3 to some power. Now the exponents on that, again, in my previous videos on finding the LCD, what's the power on 2 in the LCD? It's the greatest number of times 2 shows up in any of the factorizations of the denominators. So you see in this denominator's factorization, in 12's factorization, 2 shows up twice. You got 2 squared. And in 18, the other denominator, 2 shows up only once, right? So 2 to the first. The largest of 2 and 1 is 2, right? So that's the power on 2 in the LCD's factorization. Same thing for 3. What's the power? What's the exponent on 3 in the LCD's factorization? It's the greatest number of times 3 shows up in any of the factorizations of the denominator. So 12, 3 shows up once as a factor, 3 of the first. In 18, 3 shows up twice, 3 of the second. And the largest of these powers here, 2 and 1, is 2. All right, so the least common denominator is 2 squared times 3 squared. And that'd be 4 times 9, or 36. Okay. So I have found the LCD. The next step is to now I'm going to rewrite the fractions as an equivalent fraction. Right? So I'm going to rewrite 5/12 as something that's equal to 5/12, but with a denominator that's this LCD, that's going to be 36. Okay, so we're going to rewrite each fraction as an equivalent fraction with the LCD, right? Meaning this 36 is going to be the denominator now. All right, so I'll do that over here. All right, we've got 5/12. All right, 5/12. And I'm going to try to rewrite 5/12 as something equal to 5/12, but with a denominator of 36. So this is where multiplication by 1 comes into play. I'm going to multiply 5/12 by the number that, something that's equal to 1. That way it doesn't change its value, right? When you multiply by 1, nothing, the value of your number, your expression, does not change. So in order to do this, I'm going to multiply the numerator and the denominator by the same non-zero number. And I'm going to do so that the denominator, when I multiply, will be 36. Well, 12 times 3 would be 36, right? Or again, just think about what's missing in the factorization of 12 that's in the factorization of the LCD. The LCD has 2 squared, so does 12. The LCD has 3 squared, but 12 only has 3 of the first, so I need a 3, right? There's the missing factor. So I'm going to multiply the denominator by 3, and if you multiply the denominator by 3, I must also multiply the numerator by 3. That way it's like I'm multiplying by 3 divided by 3, and 3 divided by 3 is 1. All right. So 5/12 is equal to, 5 times 3, 15. 12 times 3 in the denominator, 36. Right? So 5/12 is equal to 15/36. And then the 5/18 over here, a little semicolon or something. 5/18, same thing. You can look at the, you can obviously tell that, I'm going to just multiply by 2 over 2 here, right? Multiply to get 36 in the denominator. But again, you can look at the factorizations. The factorization of 18 and the factorization of the LCD that I'm trying to make it into. The LCD has 2 squared. 18 only has 2 of the first, so I need to multiply by 2 of the first, right? Another factor of 2. And then, 3 squared, 3 squared, that's it. That's all that's missing is the 2. So I multiply the denominator by 2, and also the numerator by 2, right? So again, it's just like I'm multiplying by 1, right? 2 divided by 2. And in multiplying, 5 times 2 is 10 for the numerator, 18 times 2, 36 for the denominator, and now I have what I want. These two fractions I started with are now fractions that are the same value, right? This has the same value as that. This has the same value as that. They have the same value, and now they have the same denominator. So now we're looking at this. Instead of 5/12 plus 5/18, well, 5/12 plus 5/18, that'll be equivalent to 15/36 plus, and then 10/36, the same thing as 5/18. And now I have exactly what I want, right? Like over here, when we can actually add fractions together is when the denominators are the same. So you see 36, 36. So I can find their sum now. The denominator of the sum will be that common denominator. It stays 36. Doesn't become 72 or something. Alright, don't add them. The only things we are adding are the numerators. Alright, so the new numerator is 15 plus 10. So we have here 15 plus 10 is 25, and 36 is the denominator. And great, this fraction, 25/36 is the sum of 5/12 and 5/18. Now let's see if we can simplify. Right? So that actually I kind of skipped writing the third step here. So then you add, once you've got the same denominator, this LCD, then simplify if you can. Now what I mean by simplify is I want to divide out any common factors that the numerator and denominator have. Alright, so if you try taking this, let's take this over here, 25/36. If you factor the numerator completely, that's 5 times 5. Right? 5 times 5 is 25. If you factor the denominator completely, well, I've got that here, right? That's 2 times 2 times 3 times 3, right? 2 squared times 3 squared. Do you see any common factors? I don't. There's no common factor between the numerator and denominator. So this cannot be simplified any further. There's your final result then in the box. Right? So 5/12 plus 5/18 would be equivalent to 25/36. Alright, so there was an example with just numbers. I have many examples now with with variables involved. Right, but the same 3 steps will happen, the same procedure every single time. All right, I'm going to do these LCDs a little quicker now. All right, so here I'm asked to do the same thing, find the sum, and then simplify if I can. 1 divided by 8a cubed b plus 5 divided by 12ab squared. Obviously the denominators are not the same. So first I'm going to find the LCD, right? So let's factor these denominators completely. This is 2 to the third, right? 2 cubed for 8 times a to the third times b. That's 8a cubed. 12ab squared, we saw 12 in the last problem. 12 is 2 squared times 3, and then you have times a times b squared. Alright, so the LCD is going to have a power of 2 times some power of 3, right? 3 shows up in these, times some power of a times some power of b, and then the powers on these, well, the highest power of 2 I'm seeing is 2 to the third. The highest power of 3 I'm seeing in these factorizations is 3 to the first, or just 3 you can put. And then the highest power of a is a to the third. The highest power of b is b squared. So the LCD is 2 cubed, or 8 times 3. 8 times 3 is 24 times a cubed times b squared. And this is what I want to make these fractions have a denominator of. Okay, so the first fraction, 1 over a cubed, 8a cubed b. I am going to multiply the numerator and denominator by the same thing so that I get a denominator of 24a cubed b squared. And again, just look at the factors that are missing. This is 8a cubed b. Here's the LCD. They both got 2 cubed. This has a 3, that doesn't. So I'm going to multiply by 3. Right, that'll make the 24. this has a cubed, that has a cubed, this has b squared, that has only b, so I need a b as well. So I'm going to multiply the numerator and denominator by 3b, giving me 3b in the numerator, right? 3b times 1 divided by 24 a cubed b squared in the denominator. All right, and then the other fraction, 5 divided by 12ab squared. And I'm going to multiply the numerator and denominator by the same thing to change the denominator to 24a cubed b squared. So that would be, again, look at what's missing in these two here. What does the LCD have that 12ab squared doesn't? I'm missing a 2 and a squared, right, to make a cubed. So I'm going to multiply the numerator by the same thing. Multiply the numerator and denominator by 2a squared. Numerator is now 10a squared, right? 5 times 2a squared over, and the denominator is my LCD, 24a cubed b squared. Great. And now when I add them, so let's bring this down here. So 1 over a cubed b plus 8a cubed b plus 5 over 12ab squared would now be equivalent to, I'm going to change each of these fractions to these two, 3b over 24 a cubed b squared plus, and then 10a squared over 24 a cubed b squared. And now that they have the same denominator, right, the LCD here, I can now add them, all right, put them together. And once again, I'll say, when you add two fractions with the same denominator, that common denominator doesn't go away. That will be also the denominator of the sum. So 24a cubed b squared stays the denominator, and we combine the numerators. So 3b, that first numerator, plus 10a squared, the second numerator. That's the numerator of the sum. And I don't know about you, but I can't see any way to simplify this. You can factor 24 a little further, right? 24 is again 2 cubed times 3 if you want to write that. But the 3b plus 10a squared, right, there are multiple terms up here. First thing I'd look for is a greatest common factor, and these do not have a common factor other than 1. So this 3b plus 10a squared, that whole thing is the only factor of the numerator. And I am not seeing a factor of 3b plus 10a squared down here. There's only 2, 2, 2, 3, a, and b. Right? No factors that cancel. So this is it. The value of this fraction plus the value of this fraction will indeed be equal to the value of this fraction, no matter what I plug in for a and b, except for a few exceptions. So I usually like to do this, right, when there are variables and denominators, right? Remember, you can plug in whatever you want and check this. Go ahead and test it out. Plug in, 2 for a and 3 for b. 2 for a, 3 for b. Plug in 2 for a and 3 for b. Here, and then down here. And see if the value of this fraction plus this one is indeed equal to that one. But just remember that when you plug in a value for a variable or variables, the denominators can never be 0. You can never have a denominator of 0 or divide by 0. That is an undefined operation. So I'm seeing there are factors of a in that denominator, right, and that denominator, and that denominator. So hopefully it's obvious that a cannot be replaced by the number 0. Right? A cannot be equal to 0, because then I'd be dividing by 0 in all these fractions. Same thing for b. I'm seeing factors of b, in all these denominators. So again, b cannot be 0. And that looks like about it, right? All the other factors in the denominators are numbers, right? Numerical factors, and those will never be 0. So there we have it. Right? So the value of this fraction plus the value of this fraction will be equal to the value of this fraction as long as you don't replace a and b with 0. All right. And we can test it out. I'll do one little test here. Let's say we were to try just, how about a equals 1 and b equals 1? All right. Now again, they can be any values you wish. Try multiple. There are infinite possibilities. Try a equals 5 and b equals 7, and you'll see that this fraction plus this fraction equals this fraction. Well, let's see. When a is 1 and b is 1, the first fraction is 1/8 plus the second fraction would be 5/12. And before I get to this one here, let's see what this will be. Now we saw we need the same denominator. I'm hoping you're seeing here that the LCD would be 24. Alright, so I'd multiply the first fraction by 3/3, that'd be 3/24, plus, and then I'd multiply this fraction by 2/2, that'd be 10/24, and we'd get 13/24. Alright, that's the first fraction plus the second one. Well, plug in 1 for a and b in what we said the final result should be. Well, 3 times 1 is 3, plus 10 times 1 squared is 10. That's the numerator. And the denominator is 24 times 1 times 1. That's 24. And indeed, that is 13 in the numerator, 24 in the denominator. They are the same. And that should be the case no matter what you plug in for a and b, right, as long as a and b are not zeros. Right? Great. All right, my next example is very similar to that one. Add these two fractions, then simplify. Alright, so first the LCD. It's off to the side here. My denominator 15xy squared. 15 is 3 times 5, and then you have times x times y squared, or y times y if you want. 18 times x cubed times y. Again, 18 we saw before was 2 times 3 squared, 2 times 9, times x cubed times y. Alright, so the LCD, the factorization of the least common denominator, we'll have a 2 to some power, a 3 to some power, times, and then there's a 5, right, to some power. There's x's, so times x to some power, and there's y's in those factorizations, so y to some power. And again, the exponents on these are the largest number of times they appear in any factorization. So 2, the highest power of 2 is 1, 2 to the first, 2 to the nothing. Highest power of 3 is to the second. Highest power of 5 is to the first. The highest power of x is cubed, and the highest power of y is squared. Alright, so the least common denominator, the least common multiple of the denominators would be 2 times 3 squared times 5, that's 90, right? 9 times 10, times x cubed times y squared. Alright, and then I'm going to rewrite each fraction as an equivalent fraction with this denominator, right? 90x cubed y squared. So the 1 over 15xy squared. I'm going to multiply the numerator and denominator of this by the same thing, so that we get 90x cubed y squared. Well, let's see, what's that missing? It's just missing a 2 and a 3. Right, so I need a multiply by 6, right? I need to multiply by a 2 and multiply by 3. And 6 times 15 is 90. And it needs x squared, and that's it. Right, so I need to multiply the top and the bottom, the numerator and denominator, by 6x squared. And that will give me a fraction. Right, so 6x squared in the numerator, and then the 90x cubed y squared in the denominator, the LCD in the denominator. Great. Same thing for the other fraction, 7 over 18 x cubed y. Again, I'm going to multiply the numerator and denominator by the same thing, so that I get the same denominator again, this LCD in the denominator again. Alright, so again, you can look at that denominator, the 18x cubed y and the LCD. What's missing from the LCD here? They have 2's, they have 3 squareds. There's no 5, right? So I need to multiply by 5. And again, you can check 5 times 18 would be 90. They both have x cubed. This has y squared, so I'm missing a y, right, times y. And then I'm going to multiply by 5y in the numerator as well. So this gives me the fraction, 7 times 5y, 35y in the numerator, divided by, and then the 90 x cubed y squared in the denominator. Great. So now that I have these equivalent fractions, I'm going to write my sum earlier as this new sum. So this fraction plus this fraction will be equal to 6x squared over 90x cubed y squared plus, and then the second fraction was equal to this with the denominator of the LCD. So 35y over 90x cubed y squared. And now that they have the same denominator, I can now add them. So their sum, again, that common denominator will be the denominator of the sum, so 90x cubed y squared, and then you add the numerators. So 6x squared plus 35y is the new numerator. Okay, so there I have it as a single fraction, one numerator, one denominator. And then the question is, can it be simplified? Now we can factor 90 down here to 2 times 3 squared times 5. It's just the numerator again. It's two terms, so I'm looking for greatest common factor or something like that, or is it a difference of squares, difference of cubes, sum of cubes, but it's not one of those things. 6 is 2 times 3, 5 is 35 is 5 times 7. There's no common factor in these two terms to factor out. So this whole thing, right, the 6x squared plus 35y, all of that is the only factor of the numerator, and I am not seeing a 6x squared plus 35y in the denominator, so there's nothing to cancel. So this is it. This fraction is our sum. Right? So this fraction plus this fraction, whatever those values are, will be equal to this fraction here. But not all the time, right? The value of x can't be certain things, the value of y can't be certain things, and again, hopefully you're seeing that they can't be 0, right? Because I have a factor of x there, factors of x cubed, I have factors of x showing up in my denominators, so x cannot be 0, because then I'll be dividing by 0, I'll have denominators of 0. That's no good. Same thing for the y's, right? I see factors of y's in my denominators throughout this process, and the denominator can never be 0, so y can't be 0 either. So as long as the value I replace x and y with are not 0, this fraction plus this fraction will indeed have the same value as this fraction here. Okay, so there we go. And again, I'm not going to do it this time. I did it with last example, but you try it out. Plug in 2 for x and 5 for y, or 1 for x and negative 8 for y, or whatever you want. And find these values, find this value, and you'll see that the sum of these two is indeed this one here. Just so long as x and y are not 0. Right. Okay, so now, so far all my denominators have had a single term, right? These denominators have been monomials. I get a little more complex denominators, just some binomial denominators here. So here I have 5 divided by x minus 4 plus 3 divided by x plus 2, right? Now the denominators have multiple terms. This is x plus negative 4, 2 terms, x plus 2, 2 terms. All right. So again, finding the LCD. Now x minus 4, that's it. That's as factored as that gets. And same thing for x plus 2. This cannot factor any further, so all of that is the only factor of that denominator. Right? So the LCD is going to have a factor of x minus 4 to some power and a factor of x plus 2 to some power, and they both only appear once, so it's just x minus 4 to the first times x plus 2 to the first. There's your LCD. And if you want to multiply this out, fine, make it x squared minus 2x minus 8. When you FOIL, you can do that too. But I prefer to leave it in factored form, right? And the reason for that is if we keep our denominator in factored form, it'll make it that much easier to simplify the fraction after we take the sum. Alright, so this first fraction, 5 over x minus 4, I'm going to multiply the numerator and denominator by the same thing. Now again, this whole denominator is its own factor, right? I'm going to put in parentheses. This is all considered one factor. What's missing is x plus 2. Right? So I multiply it by the quantity x plus 2. And the same for the numerator. I'm going to multiply the numerator, which is only a single term, right? So I don't need to put parentheses around it. But anything with multiple terms, I'm going to put parentheses around like this down here. But I'm going to multiply the numerator by the quantity x plus 2 as well. So we're getting the denominator x minus 4 times x plus 2, that's the LCD. And then I'll actually multiply these out. So 5 times x plus 2 is 5x plus 10, right, when I distribute the 5. Okay. Alright, so there's the an equivalent to the first fraction. And the second fraction, 3 over x plus 2. Same thing. I'm going to multiply the numerator and denominator by the same factor, so that I'm not so that I'm multiplying by 1 and getting something equivalent to the original. Again, the denominator is all one factor. I'm considering all that together, and it's multiple terms, put parentheses around it, and what's missing is the x minus 4. So I'm going to multiply that denominator by the quantity x minus 4. And same thing for the numerator, multiply it by the quantity x minus 4. And again, the numerator just has a single term, so I'm only multiplying by 3. I'm not going to put parentheses around the 3. Alright, so denominator, same as earlier. Now if x plus 2 times x minus 4 is the same as x minus 4 times x plus 2. Right, when you're multiplying, it doesn't matter what order the numbers come in, the factors come in when we're dealing with the real numbers, which we are here. So this is the same as x minus 4 times x plus 2. I'll write it in the same order that I did up there. And then the numerator, 3 times x minus 4, well, I'd be distributing that 3. That'd be 3x minus 12. Right. Okay, so now, great. Now I can find the sum. So 5 over x minus 4, that's this fraction, plus 3 over x plus 2, that's this fraction. I'm just going to do this right now. I can put them together. This fraction plus this fraction, I'll put a little plus sign here, this plus this. The denominator stays the same, right? This LCD will be the denominator of the sum. And we're going to be combining the numerators, right? So the first numerator, which again I'll put in parentheses, is 5x plus 10 plus, and then the second numerator, again because it has multiple terms, I'll put in parentheses 3x minus 12. And there, and then we'll simplify the numerator, right? I mean, this is great right here. This fraction that I've just written with this numerator and this denominator, this fraction is the sum of these two fractions. It's just not totally simplified. So let's keep going with that. Now I know I put parentheses around these two terms, 5x plus 10 and 3x minus 12, but they're not really necessary here. There's nothing times, there's nothing being multiplied by the 5x plus 10. So I'm not distributing anything, I'm not raising it to powers. So the parentheses aren't needed. Same thing here. This isn't being multiplied by anything or raised to any powers, so I don't need the parentheses here either. So imagine they're not there. Now I put them though because I want you to get in the habit of doing that when I add or even subtract fractions, right? We're going to see that in the next video. When I subtract fractions especially, it's going to be important that I put numerators that I'm adding or numerators that I'm subtracting if they have multiple terms in parentheses. Alright, so now comes the simplification part. The numerator here, I've got 5x plus 3x, that's 8x when I'm combining like terms. 10 plus negative 12, 10 plus negative 12, that's minus 2. Alright, so there's the numerator. Then the denominator, again I'm going to keep it factored because I want to see if the numerator and denominator have any common factors. Alright, so again, this is great. This fraction is the sum of these two fractions, right? But again, is it simplified? Alright, so now I'm going to try factoring. Now the numerator has multiple terms. Look for the GCF that has the greatest common, these two terms, 8x and negative 2, have a greatest common factor of 2. So I'm going to factor a 2 out. And when I remove a factor of 2, what's left is 4x minus 1. Right? 2 times the quantity 4x minus 1 would be 8x minus 2. And that's as factored as the numerator would get. And again, I kept the denominator in factored form already. And I don't see any common factors, do you? You know, there's a 2, there's no factors of 2 down here. Yes, there is a 2 here, but it's not a factor of 2. It's not, there's no times 2. Multiplication by 2. 4x minus 1, there's a factor up there. There's no 4x minus 1 down there. So this is as simple as it gets. And in fact, I would probably just leave it like this. You could also multiply everything out. Keep the numerator as 8x minus 2. And then the denominator, since it's simplified, right, there's no common factor, multiply everything out, and the denominator is x squared minus 2x minus 8. You can write that as well. All three of these things here are the same. And just one more little thing too is, yes, this fraction plus this fraction will indeed be equal to this fraction here, but not all the time, right? Not for any value of x. So look at the denominators again. There's factors of x minus 4 showing up in the denominator. So the value of x cannot be replaced by positive 4. Right? If I replace x with 4, that'll make that denominator 0, it'll make that denominator 0. So that's no good. But also, I'm seeing factors of x plus 2, right, show up in my denominators. So x cannot be negative 2 either. Right? Because if x were negative 2, I'd have a denominator of 0. And those look like the only factors with variables that show up in the denominator. So here we go, right here. This fraction plus this fraction is equal to this fraction as long as the value you replace x with is not one of these two, is not 4 or negative 2. And again, try it out. Plug in 1 for x, 5, 3.5, 2/3, plug in whatever you want for x as long as it's not these two, and this plus this will be equal to this value here, and you can check that out yourself. Alright, so again, I got several more, and it's going to be a long one today. And feel free to skip ahead, skip around, look through specific examples if you want. Alright, so another similar problem. Negative 1 over denominator n minus 3 plus, and then 4 over n plus 1. Alright, so hopefully you're seeing that the LCD here is n minus 3, that's the only factor of this denominator, times, and then n plus 1, the only factor of that denominator. And again, if you want to multiply it out, it'd be n squared minus 2n minus 3. But I'm going to leave it in factored form. Alright, so the first fraction, so I have negative 1 over, and then n minus 3. I'm going to multiply this numerator and denominator by, now the only missing factor in the denominator there would be n plus 1. And again, I'm going to put this in parentheses because it has multiple terms. I'm multiplying this whole thing by the quantity n plus 1. And same thing up here. Now this has one term, so I'm not going to put it in parentheses. You can if you want. Wouldn't be wrong. And then I'll multiply this by the quantity n plus 1 as well. And when multiplying this, I get my denominator, I get my LCD, n minus 3 times n plus 1. And then distributing the negative 1, we have minus n minus 1 up in the numerator, right? Negative 1n plus negative 1 in the numerator. Okay, the second fraction, 4 over the n plus 1, same thing. I'm going to multiply the numerator and denominator by the same expression. What the factor is missing is the n minus 3, and again, you're multiplying this whole denominator. It's got multiple terms. I'm putting it in parentheses, times n minus 3. And I'm doing the same to the numerator, times n minus 3. So it stays the same value. It's like I'm multiplying by 1. The denominator is that LCD, n minus 3 times n plus 1. Again, it doesn't really matter what order you multiply things in real numbers. And then distributing the 4 up here, we have 4n minus 12, right? 4 times n minus 4 times 3. Alright, now we're going to be adding these, right? This fraction is now this fraction is now this fraction, and we're adding them. I put a little plus sign here. They have the same denominator. Alright, so the resulting sum will have that denominator, and again I'm going to keep it factored. So n minus 3 times n plus 1, and we're adding the numerators. So the first numerator is this negative n minus 1, and again it's got multiple terms, so I'm going to put in parentheses. Even though they're not really necessary here, I'm going to still put them in parentheses. It doesn't hurt. Plus, and then the second numerator is again in multiple terms, so I'm going to put it in parentheses, plus the second numerator of 4n minus 12. Alright, and then we're going to combine, simplify it. This isn't wrong. Right? This fraction I've just written is the sum of these two fractions. These two fractions, combine to make a single fraction. But it's not simplified, right? We're going to combine like terms in the numerator. All right, so my numerator, I have negative 1n plus 4n, that's positive 3n. I have negative 1 plus negative 12, that'd be negative 13. And there's the numerator. And then the denominator is, again, this n minus 3 times n plus 1, the LCD. And then we try to say, and again, this is great too. This is the sum of these two fractions right here. Is it simplified though? Now this time the numerator, 3n minus 13, the GCF of those two terms is 1, greatest common factor. So this, if you want, you can put it all in parentheses. This 3n minus 13 is the only factor of the numerator, and I am not seeing a 3n minus 13 quantity in the denominator, factor in the denominator. So this is as simplified as it gets. And again, if you'd like, you can multiply out the denominator. Now that I know it's simplified, I can write everything without, some people don't like parentheses and things at the end for some reason. So 3n minus 13 in the numerator, and then n squared minus 2n minus 3 in the denominator. Same thing. You can leave them like this or this. And then just off to the side again, some values that I cannot replace n with. Right? This fraction plus this fraction will be equal to this fraction here. You can check it out, plug in values for n and test it. But the only ones that aren't any good are 3 and negative 1, right? Because if I replace n with 3, this denominator is 0, that denominator is 0. If I replace n with negative 1, this denominator is 0, that denominator is 0. You can't have denominators of 0. You can't divide by 0. So this is the correct response. This is the correct sum, as long as the value of n is not 3 or negative 1, right? But replace n with anything else and try it out. Replace n with 0, 5, 100, 1,000,000, whatever you want, and this plus this will be equal to this. Alright, so now I'm getting into some ones with quadratic denominators. Again, long video today. Sorry. Skip around if you want. So here, negative, z plus 1 numerator divided by z squared plus 7z plus 10 plus, and then 2 over z plus 5. Let's find the LCD. Alright, so z squared plus 7z plus 10, that denominator, when you factor it, again, you can look for a video I put up on factoring quadratics, or look for others, or look in your book or whatever. But this would factor to z plus 5 times z plus 2. And you can check by multiplying. The other denominator is just simply z plus 5, and that is the only factor of that denominator. Alright, so the LCD is going to have z plus 5, right? Z plus 5 showing up to some power times, z plus 2 is another factor that shows up, right? Times z plus 2 to some power. And z plus 5 appears once in this and once in that, so power of 1 in the LCD. And z plus 2 appears 0 times in this, once in that, so it has a power of 1 in the LCD. So this is it. And again, if you want, you can just write this as z squared plus 7z plus 10. All right, so the LCD is z plus 5 times z plus 2, or z squared plus 7z plus 10. So this first fraction has the LCD already, right? This denominator is the LCD already. So the only fraction I need to change is this one here. All right, now I'm going to rewrite the first one, negative z plus 1, so that the denominator is factored, right? I like to have my factored denominators before adding or subtracting. And again, that's only for purposes of simplification of the fraction later. So instead of negative z plus 1 over z squared plus 7z plus 10, I'm going to rewrite that as negative z plus 1 over z plus 5 times z plus 2. Okay, then this other fraction, 2 over z plus 5, and I'm going to multiply that numerator and denominator by the same thing, and that would be the z plus 2, right? That's missing. And it's the I'll put it in parentheses, it's got multiple terms. Same thing for the z plus 5, I put that in parentheses, it's got multiple terms. And the denominator will be that z plus 5 times z plus 2. The numerator is, got 2 times this, distribute the 2, is 2z plus 4. Okay, and now we're doing this. We're adding these two fractions right here. This is this fraction, this is this fraction now, and we're adding them. They have the same denominator now, right, the LCD, so that will be the denominator of the sum. So the quantity z plus 5 times the quantity z plus 2. And I'm adding the numerators. So again, you got the first numerator is this negative z plus 1 plus, and again, multiple terms, so I'm putting in parentheses, even though they're not really necessary here, plus the second numerator, 2z plus 4, and great, this is the sum of those two fractions, but I want to simplify. So I combine like terms in the numerator. Negative z plus 2z would be 1z, and then 1 plus 4, I've got positive 1 plus positive 4, that's positive 5. And then divided by, z plus 5 times z plus 2. All right. Again, great. This is the sum of these two fractions. It's just, is it simplified, right? So I try factoring everything. Now, I've already written the denominator factored. All right. The denominator is already in nice factored form. The numerator has the greatest common factor. This has multiple terms. You look for the greatest common factor. The greatest common factor is 1. So there's nothing to pull out here. So this entire thing, all of it, is the only factor of the numerator other than 1. And I do see it now, right? There is some simplification going on here. This and this, right? The numerator and denominator have a common factor of z plus 5. Now remember, when you divide those out, technically these become 1, right? Anything divided by itself is 1. So what I'm left with at the end is 1 divided by, 1's the only thing left in the numerator. And then the only thing left, the only factor left in the denominator is z plus 2. And since it's the only factor left, there's really no need to have parentheses around it. So yes, this fraction plus this fraction will be equal to this fraction here. For anything you plug in for z, with a few exceptions though. Right? Remember, throughout the entire process, the entire problem, denominators cannot be 0. So yes, this fraction plus this fraction will be equal to this fraction, but I cannot replace z, so z cannot be equal to, let's see, there were factors of z plus 5 showing up in denominators, right? Z plus 5. So z can't be negative 5. You cannot replace z with negative 5 in this problem. Also, right, there were factors of z plus 2 showing up in my denominators, right? So z can't be negative 2 either. But anything else is fine, right? I'm not seeing any other factors showing up in the denominators anywhere. So anything else is okay. And check it out. Try it out. Replace z with, say 0. This would be 1/10 plus 2/5. So 1/10 plus 4/10, that's 5/10, that's a half. When z is 0 down here, that's a half. You'd get a half equals a half. Fantastic. And that should work out every time. as long as z is not -5 or -2, right? Replace z with 100, 1, 3, -8, whatever you want, and this plus this will be equal to this. Alright, so here's another one with some quadratics. I just got a few more here, probably going to go a little over an hour. We'll see. Another one, right? Two fractions, let's find the LCD. So the first denominator is, x squared plus 5x. That factors, these have a greatest common factor of x. I pull that out. That's x times x plus 5. And then the other denominator, x squared minus 5x. Again, these two terms have a greatest common factor of x. I pull that out. X times x minus 5. So the LCD is going to have, I see factors of x showing up here. So I'll have x to some power times, I see a factor of x plus 5 showing up in these. So x plus 5 to some power. And then again, I see a factor of x minus 5. So I have x minus 5 to some power. And then, x appears once there, so to the first power. X plus 5 shows up once here, 0 times here, so to the first power. And x minus 5 shows up once here and 0 times here, so again to the first power. So this is your LCD. And again, if you want to multiply it out, be my guest, but I'm going to, again, like I said before, I like to leave my denominators factored to make simplification at the end easier. Okay, so these fractions, so 1 over, and again I'm going to write this as factored, that's x times x plus 5. I'm going to multiply that numerator and denominator by the same thing. And what's missing in x times x plus 5 in the LCD is x minus 5. So I'll multiply that by the factor x minus 5, same thing for the numerator. Right? And that gives me this here. Now 1 times anything is itself, so the numerator now is x minus 5. And the denominator is the product, this LCD, right? The x times x plus 5 times x minus 5. Great. The other fraction, 1 over, and again I like to write I'm going to write my denominators in factored form, x times x minus 5. And multiply the numerator and denominator of this by the same thing, and what's missing is the x plus 5, that factor, the quantity x plus 5. And I do the same to the numerator. Alright, so same problem here, multiply by 1, you just get x plus 5 in the numerator, over, and then the LCD, x times, and I'm just rearranging so I write it in the same order, x times x plus 5 times x minus 5. Right, then we're adding these, right? So this fraction is now this fraction is now that fraction, and we are adding them. But now that I'm adding them, and they have the same denominator, that denominator, right, will be the denominator of the sum. So x times x plus 5 times x minus 5 is the denominator of the sum. And I'm not going to do it this time. I'm going to kind of skip ahead. Remember, we're taking this whole numerator here plus this whole numerator here. X plus, and simplifying, right? X plus x combined to make 2x, and then negative 5 plus positive 5 would make 0. So all I have now is 2 times x. So there are two factors, 2 times x in the numerator there. And this is great. I mean, this fraction is the sum of this fraction and this fraction. It's just, again, is it simplified? Now look at the factors, right? Now this is a product in the numerator. It's 2 times x, so factors of 2 and x. And look, I am seeing another factor of x in the denominator. So those are common factors. Those cancel. Those, you can divide those out. A little more colorful here, so you can see it. And those become 1 technically. So 2 times 1, and then 1 times x plus 5 times x minus 5. Alright, so when all is said and done, after I've canceled my common factors in the numerator and denominator, the numerator is 2 times 1, or 2. And the denominator is now getting rid of that factor of x, x plus 5 times x minus 5. Or if you want, 2 over, x squared minus 25, right, if you multiply x minus 5 times x plus 5. But I'm going to leave it with the factored denominator. I don't know, there's nothing wrong with it. It's totally simplified. Okay, so again, this fraction plus this fraction is now this fraction, and you can test it out. But it's not always the case. Right? You can't plug in any number for x. So remember, the denominator can never be 0 in the entire problem. You can never divide by 0. So looking through this problem here, I noticed that there were times where in the denominator I had a factor of x, just x. So x can't be 0 in this problem. You cannot replace x with 0. That'll make denominators 0 throughout the problem. And then there were factors of x plus 5, right, showing up. So x can't be negative 5. That'll make those denominators 0. And there were also factors of x minus 5 showing up in denominators. So x can't be positive 5 either. So there are 3 numbers, right, and those are the only factors I saw in any denominator. So there are 3 numbers that I can't plug in. So test it out. Try plugging it. Replace x with anything you want besides these 3. 1, 2, 3, 8, a million, a third, a fifth, pi, square root of 2, whatever. And see if the value of this fraction plus the value of that fraction is indeed equal to this one here. And you will see it is the case. All right, so I got one more, well, a few more. Okay, next one. Now this time, right, the difference between this one and previous examples is now the numerators are not just a single term. Right, now the numerators have multiple terms, x minus x and negative 2, and then x and positive 3. All right, but the same procedure. All right, you still work through the same procedure. Find the LCD, right? So I'm going to take the first denominator, x squared minus 3x, factor it. I would pull x out, and that'd be x times x minus 3. Then the other denominator, 4x minus 12, would have a greatest common factor of 4, and then times x minus 3. And then you can break 4 up to, again, 2 squared, right? 2 times 2, so that's 2 squared times x minus 3. So the LCD, right, is going to have 2 to some power, x minus 3 to some power, and x to some power. Right? I'm seeing x and x minus 3, all these factors showing up. And then the powers on these factors, 2x and x minus 3. Power on 2, 2 appears twice here, 0 times there, so 2 to the second, the highest number of those. X appears once here, 0 times there, so x to the first. X minus 3 appears once in both of them. So there we go. The LCD is 4 times x minus 3, right? Or 2 squared times x minus 3. So I'm going to try to rewrite these fractions with this denominator. Right? So let's do that. All right, so the first fraction, so x minus 2 over, and again I like to have the denominators be factored, x times x minus 3. And we're going to multiply the numerator and denominator of this by the same thing, so that I get this 4x times x minus 3. All it's missing is 4, right? So I'm going to multiply the top and bottom by 4. Now, notice here, the numerator now has, multiple terms, more than one term. So we're not just multiplying the x by 4, we're multiplying all of it, right? So again, as I've been doing in previous examples, when something has multiple terms, I put it in parentheses. Alright, so then after multiplying, we'll be distributing the 4 here. That'd be 4x minus 8 in the numerator, divided by, and then your 4 times x minus 3, or 2 squared times x minus 3, whatever, the LCD in the denominator. Great. Then the other fraction, you have x plus 3 in the numerator, over, and then, again, I like to have my denominators be factored, 4 times x minus 3, or 2 squared times x minus 3, and then the only thing that's missing, right, when I multiply the numerator and denominator by the same thing, the only thing that's missing is the x. So multiply by x, multiply the numerator by x, and again, you're not just multiplying one of these terms by x, you're doing it to the whole thing. Right, multiplying the whole numerator, both these terms by x. So again, parentheses around things with multiple terms. So I'll be distributing the x up here, giving me x squared plus 3x, right, when I multiply that. And again, denominators stay factored. 4 times x minus 3. All right. And then we're going to be adding these, right? So a big plus between there. So that fraction is now this fraction is now this fraction, and then we're adding them. Now the sum, right, remember the sum, now that they have the same denominator, that denominator is the denominator of the sum. So I have 4 times x minus 3, and then we're combining the numerators. Now remember, I'm taking this whole numerator plus this whole numerator, right? Well, let's see. Now I personally like to write, and if you've seen other videos of mine, I like to write polynomials in descending order with respect to one of the variables. So I'm going to put the highest power of x first, and I'm seeing that's x squared when I add these two numerators, this numerator and this numerator. So there's 1x squared. There's a positive 4x plus positive 3x, so it'll be plus 7x. And then you got negative 8, and there's no other numbers in these numerators, so that's it, negative 8 term. Okay, great. This fraction is indeed the sum of these two fractions. But is it simplified? So now the denominator is already factored, and again, if you want to write 4 as 2 squared, fine, but it's already factored. I can factor the numerator, though, further, can't I? All right, that's a nice quadratic trinomial, x squared plus 7x minus 8. That factors to x plus 8 times x minus 1. Right? And if you multiply that out, you'd get x squared plus 7x minus 8. And then divided by, and then you got 4 times x minus 3. And this is great too. This fraction is now, numerator's factored, denominator's factored now. This fraction is the sum of these two. Now I'm not seeing this time any common factors. There's no x plus 8 in the denominator. There's no x minus 1 in the denominator. So this is great. All right. So you can leave it like this, or if you want, actually keep the numerator the way it was. If you don't like parentheses, right? Some people don't like parentheses at the end. So keep the numerator as x squared plus 7x minus 8. And distribute the 4x in the denominator, make that 4x squared minus 12x. I mean, that's fine too. But I'll leave it like this, where everything's factored and we see that it's simplified, right? We see that there's no common factor in the numerator and denominator. But again, as with the previous examples, I'm going to put here off to the side, values of x that would make this no good. So yes, this fraction plus this fraction will be the same value as this fraction here. It's just, I'm seeing factors of x show up in the denominator, so x cannot be 0. That'll make, these denominators with x as a factor equal to 0. I'm also seeing factors of x minus 3 in the denominators, so x cannot be 3 either. And those are the only factors with variables that show up. Yeah, there's 4, and but 4 is never going to be 0, right? 4 doesn't have any variables. So those are the only factors with variables that show up in the denominators. So 0 and 3 are the only values that are no good. I cannot plug those in, but anything else is fine. So this fraction plus this fraction will be equal to this fraction, as long as I plug in a number that's not 0 or 3. And try it out. Plug in 1, plug in 2, plug in 2.5, plug in 5, a million, whatever you want, in for x here, here, and here, and see that indeed those are equivalent. All right. So this next one I've got has a little trickier one. All right. There's a quadratic numerator this time, and this time this denominator is not in descending order, right? Again, as I mentioned, I like to have my polynomials in descending order, but the same procedure holds. All right. So I'm going to find the LCD. So I'll take the first denominator here, p squared plus p minus 2, and we're going to factor it. That'll be p plus 2 times p minus 1. Then the other denominator, 1 minus p, as I've mentioned, I do not like that. I don't like 1 minus p. I like to put my polynomials in descending order, highest power of the variable. I'm looking at highest power of a certain variable first. Here that's p. So I'm going to rewrite this as negative p plus 1 and then factor it. Right, put the highest power of p, negative p, and then the plus 1. And now, and if you've seen videos of mine on factoring earlier, or you've probably heard me say this, try factoring this thing. Well, the greatest common factor of these two terms is 1, but the lead coefficient is negative, right? Since the lead is negative, what I'm going to do is I'm going to factor out negative 1, the opposite of the greatest common factor. So I pull out negative 1, and if you want, you can put that in parentheses or something. That is a factor times, and then if I pull out negative 1, the other factor would be p minus 1. Okay. So the LCD is, I've got this negative 1 here. I've got a p minus 1. And I've got p minus 1 showing up. I've got negative 1 showing up, and I got p plus 2 showing up. So there's the LCD, and then all the powers on these would be 1, right? There's only one negative 1 there. There's only one p plus 2. There's only one p minus 1 in both of them. So the highest power of any of these is 1 in any of the factorizations. Okay. So just as before, just as all the other examples, now that I've found the LCD, I'm going to try to get these two fractions to be equivalent fractions with this denominator. So the first fraction, I've got 2p squared minus 8. I'm going to write all my denominators in factored form. So negative 1, the p squared plus p minus 2, that's p plus 2 times p minus 1. Okay. So there's nothing there, nothing where that block is, that little black mark is. And then I'm going to multiply the numerator and denominator by the same thing so that we get this to look like this. Now the only thing that's missing is a negative 1. Alright, and then the numerator has multiple terms. Alright, so I'm going to put that in parentheses. We're going to be distributing this negative 1. So that'd be, after distributing, that'd be negative 2p squared plus 8 is the numerator now. Right, divided by this LCD, negative 1 times p plus 2 times p minus 1. Okay. Again, doesn't matter the order. Alright, and the other fraction, p plus 1 over. And again, the way I had it factored, I'm going to pull out negative 1, negative 1 times p minus 1. That's the same denominator as 1 minus p. I'm going to multiply the numerator and denominator by the same thing, so we get it to be the LCD. The only thing missing is the p plus 2. So p plus 2, p plus 2. And again, you're not just multiplying p plus 2 by one of these terms, you're doing the whole thing, right? It's got multiple terms, I'm going to put in parentheses. Alright, now in multiplying, right, we would have to FOIL, you'd have to distribute the p, and then distribute the 1, and then combine like terms. P plus 1 times p plus 2 would be p squared plus, plus 1 plus 2p plus 1p, so plus 3p, and then plus 1 times 2 plus 2. Alright. And then again, the denominator is the LCD, negative 1 times p plus 2 times p minus 1. Alright, then we're adding these, right? Put a plus sign between them. This fraction is now this fraction. This fraction is now this fraction, and we are adding them. They have the same denominator, so their sum will have that denominator, right? Negative 1 as a factor, p plus 2 as a factor, p minus 1 as a factor. And remember, we're adding the numerators, right? This whole numerator, blue marker stinks. This numerator, right? So all those terms plus this whole numerator. And I'm going to combine like terms and write it in descending order. So we have negative 2p squared plus 1p squared be negative 1p squared, so minus p squared. There's no p to the first up here, so 0p if you want, plus 3p is positive 3p. And then positive 8 plus positive 2 is positive 10. Alright, and this is all great. This is wonderful. This fraction is the sum of these two. Right? But is it simplified? Now, as before, well, I have the denominator totally factored. I'm going to factor the numerator. Alright, now the lead coefficient is negative, and as I mentioned before, when the lead is negative, I'm going to pull out a negative. So I'm going to pull out negative 1, right, because the greatest common factor of these three terms, negative p squared, 3p, and 10, is 1. So I'm going to pull out negative 1 because the lead coefficient is negative. So I've got a negative 1 pulled out, times, and then hopefully you can see this, right? Don't have a lot of space here. Maybe I'll do it off to the side. I'd have negative 1 pulled out. So this is actually going to go here, right? And when I pull negative 1 out of this, this would be p squared minus 3p and then minus 10. And then p squared minus 3p minus 10, that can factor even further to p minus 5 times p plus 2. And you can double check, take p minus 5 times p plus 2, you're going to get p squared minus 3p minus 10. So there's the numerator totally factored. And here's the denominator totally factored, right, the LCD. And you see, hopefully you can see the common factors that the numerator and denominator have. Right, I'm seeing now they both have this negative 1, right, that makes 1. And they both have this factor of p plus 2. So when I'm all said and done here, all that's left, the only factor left in the numerator is p minus 5, and since it's the only factor left, I don't need parentheses around it. You can put parentheses around it if you want, that won't be wrong, it's just not good looking. And then the only factor left in the denominator is p minus 1. Alright, so this is great. This little fraction here is the sum of this fraction and this fraction, but not all the time. Remember, there are always, if there are variables in denominators, there's a good chance there are some values you can't plug in, right? Because I don't want to divide by 0. I don't want to have denominators of 0. So looking back through the problem, I have noticed that there are factors of p plus 2 in some denominators, so p cannot be negative 2. That would make those 0. I have also seen that there are factors of p minus 1 in denominators, so p cannot be 1 either. So this is all good. Sorry about the edge of the page here. But so this fraction plus this fraction is equal to this fraction, p minus 5 divided by p minus 1, as long as the value of p is not negative 2 or 1. And try it out. Plug in 0. I think 0 would be an easy one to do out loud here. If p were 0, this would be negative 8 over negative 2. Now negative 8 divided by negative 2 would be positive 4. And 0 here and here would make this 1 over 1. So 4 plus 1 is 5. I'd get 5 up here when p is 0. And look at this when p is 0. What we said the final result would be the final sum. 0 minus 5, 0 minus 1. Negative 5 divided by negative 1, that's positive 5. I'd get 5 equals 5. Great. And that will work all the time. Plug in anything you want for p. It won't always be 5, it might be like 3 halves equals 3 halves or something, but whatever you plug in for p, this value, the value of the sum of these two fractions will be equal to the value of this fraction as long as p is not one of these two numbers. Alright, and then now finally, I have one last example. This is just one to show, remind you that when there's not a denominator, there really is. Okay? So if I say find this sum and simplify, 2 plus and then the fraction 3 divided by x minus 1. I just want to remind you that when there is no denominator, right? You're like, oh, there's no denominator here. How can I find the least common? The least common denominator. When there's no denominator, technically you can always put a divided by 1. Isn't anything divided by 1 just itself, right? So 2 on its own is the same as 2 divided by 1, or 2 over 1. So it's the same thing as 2 over 1 plus 3 over x minus 1. All right, and then we'll go now hopefully you can see that the LCD is simply the factor, just x minus 1. Again, it's the only factor, so I really didn't need to put parentheses, but it's just x minus 1, right? It would be x minus 1 times 1. All right. Then changing the fractions, so 2 over 1. Let's start with that fraction. Multiply the top and bottom by this LCD. The only thing missing is x minus 1. Right? So multiply the top and bottom by the quantity, x minus 1. Right, and again, I say the whole thing, right, because we're going to be distributing the 2. You're not just multiplying the x by 2, but all of it, right, the whole thing, x minus 1. So the numerator would be 2x minus 2, and the denominator would be this, again, if you want to put it in parentheses, fine, but it's the only factor in the denominator, so divided by x minus 1. Great. The other fraction, 3 over x minus 1, it's already done, right? The denominator is already the LCD, 1 times x minus 1. And so now we're adding these, right? We're going to be adding these guys. So this fraction became this fraction stayed the same, and we're adding them, right? So the sum will have that common denominator, x minus 1, and then you add the numerators. Right? So again, you're adding, this has multiple terms, so I'll put in parentheses, you're taking this numerator, 2x minus 2, plus 3. So there's only 2x plus no x would be 2x, and then negative 2 plus 3, negative 2 plus 3 would be plus 1. And then you're saying, great, this fraction here is the sum of these two fractions, these two original guys here. Wonderful. Is it simplified though? Well, the GCF of the numerator is 1, so that's it. 2x plus 1. This whole thing, I could put in parentheses if I want, that 2x plus 1 is the only factor of the numerator. And I am not seeing a factor of the quantity 2x plus 1. I'm not seeing 2x plus 1 in parentheses in the denominator, so that's it. There are no common factors in the numerator and denominator. This is as simple as it gets. So that's it. This fraction is the sum. Alright, so this fraction plus this fraction will be equal to this fraction here for any value of x except, hopefully you can see that 1 is no good. Alright, so off to the side here I write x cannot be the number 1. Alright, because if I replace x with 1, that'll make all these denominators with an x minus 1 in it, that'll make those denominators 0, and that is no good. And go ahead and try it out, test it out. I think an easy one to say out loud here would just be if x were 2. Alright, if x were 2, this would be 2 plus 3 over, 2 minus 1 is 1. So that's just 3 over 1, that's 3. 2 plus 3 is 5. You get 5 up there. And when x is 2, 2 times 2 is 4, plus 1 is 5, over 2 minus 1 is 1, 5 over 1 is 5. You get 5 equals 5. They are the same value. And it's not always going to be 5, right? But plug in whatever you want. Plug in 0, plug in negative 5, plug in anything else other than 1, and this plus this will equal to this value here. Great. All right, so I know that was a long one. All right, and again, you can hopefully you didn't. If you got the gist of it after the first few examples, maybe you stopped it and practiced some more problems on your own. But other than that, got plenty to work with here, plenty of examples of adding fractions where you need to find the least common denominator. Right, you got to find the least common denominator, get the fractions to have that common denominator, and then add them and simplify. Right, add them and then factor the numerator, factor the denominator, cancel any common factors. I know it's a lot, and it is a lot, but it's what's necessary. And as always, at the end of these, I like to say, please, try your best to get through, understand material on your own before looking for help, because I find that when people get it on their own, get it with their own hard work, it sticks better. They seem to remember it better if they've accomplished it on their own. Read through the text, read through the author's examples, try to understand them, try to even work out the author's examples before reading how the author did it. Work through problems in the backs of the sections, find, look up answers, see how you're doing, and don't just give up after the first try, please. Right? Don't get so frustrated so early. If after several attempts of a problem you're still not getting it, it's still not clicking, go back and read the material again. Maybe a second or even third read through of the material and the author's examples will give you that aha moment. Maybe something will click the second or third time through that didn't click the first time through, because now you've actually seen more examples and worked on some problems. But if after several read-throughs of the material and several attempts at problems, you're still not getting it, it's still not clicking, It is not a sign of weakness whatsoever to go looking for help. That is what other people are there for. Ask a tutor, ask a teacher, ask a friend in the class or some other person who knows the material well to help you. Look for videos on the subject like this one or plenty of other better ones, shorter ones out there, I promise you. And just keep at it, stay persistent, and I know you'll eventually get it. I just know you will. And try your best to have fun with it. Have that I'm enjoying this mentality from the get-go. Don't just immediately say I hate this, I hate this, I hate this, and because you're just gonna hate it, and it's gonna be boring and terrible. It's all about mindset. Okay, so try to have fun with it, and I know you can get it. Just keep persistent, and thank you for watching.